Hello and welcome. Today we will be looking at the flood area for Pointinput tool and how to use it. There are two main usages for the tool. For one, you can extract or inject water in your map using the Pointinput tool, or you can pump water from one point to another in your map. To use the tool, at first we have to create a new line shape. So we do that right now. It will be called Pointinput and it will be a polyline. We have to choose our coordinate system. And here you can see our new empty line shape file. Before we start adding lines, we open the attribute table and we have to add some new fields. For example, our first field will be the discharge field and it will be in float. Then we will have a comment field, just text. We will have a target field. We will have a threshold field. And we can add a scenario field. The scenario field is important if you want some of your point inputs to be activated or deactivated and others not, so you can give them different scenario numbers and some of them will be active and others won't. Okay, now we have our attribute table ready and we can start editing. For example, we have here a field and there's a ditch in the field and it's crossed by a street, and we know there's a culvert connecting these two parts of the ditch. Water is flowing from here to there, so we connect the two ditches by a line starting at the end of our first ditch and ending at the beginning of our second ditch. You might want to change the symbology so you can see better in which direction you created the line. And for that, the arrow symbology is quite useful, because it's really important from which side you start and where you end, because it will always extract water at the beginning of your line and inject it at the end of your line. So the direction in which you create your line is important. So I will continue to create some pump lines along the ditch. You can see now some lines I added along this ditch. And for them, I assume that it's all 50 centimeter in diameter pipes. So I can add that into the comment section. And the discharge value is calculated by using the diameter of the pipe. For example, for a 50 centimeter pipe, it would be a discharge value of 0.7 cubic meters per second. And I can add that in for every of these lines. We have kind of a special case down here. Here you can see a pond, and let's say the pond is connected to the ditch. It has an outlet that flows into the ditch. So we create it here. There's a pipe going from here to there. And the special thing about it is that we say that the pipe isn't on ground level, but the outlet is higher. It's, for example, 50 centimeter above ground. So we type in a threshold value, and this pump line here will only start to pump water from this pixel to this pixel if a water level of 50 centimeter or more is reached here. And for the discharge value, I will type in 0.3 because I want to be the pond pipe smaller. And now to our last special case. Down here we have a ditch that is where water, we have a ditch where water is flowing from here to there, and then the ditch stops. It just ends, and there's no new ditch on the other side of the road. And we know that the ditch is connected to a sewer system here, and the water is going down into the sewers. And we don't have any knowledge about the sewer system, so for our simulation, the water is just disappearing out of the testing area. And to simulate that, we create just the same line. And it's not really important where it ends, only the beginning, because now our target column will be important. We don't know where the line ends, we just want water to be extracted here, so we leave it at 0. For all the other lines, we type in a 1 because we know where the water is going and it reappears. And only our last pump line here will remain with 0, so water just gets extracted. For scenario, I could type in different numbers here, but for now we will just leave it with a 1 for scenario number 1 for every line here, because we want to include them all in our simulation. And I want the discharge of wave point to be 1 cubic meter per second. Save our edits, stop editing, and now we can start the generate hydrofile tool in the FloodArea toolbox. First we have to put in our shapefile. Then we have to specify which field gives us the discharge values, which will be the discharge field. We have to give an output directory. We could put in here an hydrograph text file as an example file from which, for example, time steps or something like that will be taken, but we don't need it. We have to specify the usage of target of coordinates, which will be our target field. If there's a 1, it will use the target coordinates. If there's a 0, it won't use it, which is specified down here with 0. Here we could give our scenario, and here the last field is for threshold. And we can start generating the hydrofile. And now you can see here we have 2 text files generated. We can now take a look at them. First, our coordinates file. We open that with an editor. Let me just reorganize it a bit so you can read it better. Okay, now at first we can look at the new IDs the lines got. We had a line number 0, the first one, and we have the coordinates for the beginning, the 0a, and the endpoint, the 0e. And this one line got divided in these two line numbers. We start at 1, and it tells us where it pumps the water from number 0 to number 1. And at number 1 is a -1, and it just tells that here the water is injected, not extracted. Everywhere where a -1 is, water is injected. And then it goes on from line 2, water is extracted and injected at line 3. And from 4 it goes to 5, and from 6 to 7. And here you can see our line number 12 has only beginning but no end coordinate, because there's just water being extracted. So that you can also see here, because there's at pump 2 only a -1 and no different line specified where the water should end. And the last special feature you can see here is at the minimum water level column, that down here at our pond line is the 50 centimeters specified. So that's everything included in our coordinate file. And if we now have a look in the hydrograph file, okay, now you can see here some columns, one for time. It's in hours, and because we didn't specify any time steps, we only have a 0 for the beginning of our simulation, and then the whole thing ends after 8,760 hours. But because our simulation is only taking 3 hours, it will stop when the simulation ends. So this number here doesn't really matter, as long as it's equal the size or bigger than the simulation time. Then you can see here our different extraction and injection points. You can see at point 0a, the beginning of line 0, it takes 0.7 cubic meters, and then this amount of water is injected to line number to the endpoint of line 00e. And the 0 under the endpoint just indicates that there's no water taken, but only injected water that it gets from the beginning point. And you can see that it's the case for nearly all of our lines, except for our last line, number 6, the one that went in the sewer system, and there's only a beginning point, and it extracts 1 cubic meter per second, and has no end point where it is injected, so the water just leaves the simulation. Also, you should keep in mind that if you want to add lines, you have to keep in mind that the order should be maintained, so that line number 1a is right next to line number 1e, because FloodArea doesn't read the naming of the columns. So it will only give water from the first column to the second column and doesn't mind how it's called. So if you would add another pump line here in between 0e and 0a, that would mess up the simulation. One last thing I want to show is the opposite of our point 6a. It's a point where you inject water. For example, we have in a residential area, in our testing area, a manhole cover where at heavy rainstorms the sewer system is overflowing, and we want to simulate that. So we can add in here another line number 13, and I have some coordinates for our manhole. And again, here is no target, it just gets out at this beginning point. So again, -1, here 0, 0, hashtag OD, and it will be 7A. So we have no target, only the beginning point. So in our hydrograph file, we also only have to insert beginning point 7A. And because we don't want to extract water, but to inject water, we don't need negative values, but positive. So I want to inject 1.5 cubic meters per second at our manhole in the map for the whole time of the simulation. And that's all for our preparations, and we can start the simulation. So the simulation finished, and now you can see results. Here you can see an area where we didn't include any pumps where culverts are, so you can see quite well how the ditch is overflowing where it ends and no culverts are included. And on the other hand, you can see where we insert pumps that the ditch is not overflowing and the water is just pumped from one end to the other. So that's all for now, and thanks for watching.